So we'll pick up here with the back-to-back stem and leaf plots, and it's a similar setup to a regular stem and leaf plot, except it's going to allow us to compare two similar sets of data, where we put the stems down the middle, and then we're going to send one set of data to the left, and then one set of data to the right. So maybe we look at heights. If we were to look at the class, and we could see that um, the data could be split into males and females. So here we go with, here's all the males in this particular group. We'll highlight this, we can tell the difference. And then down the middle, for title of heights, and then down the middle we'll put our stems. Just like the previous stem and leaf plot, we'll split the stems just to kind of be able to see the difference between things. But we'll put males on the left side, females on the right side, and then start picking through and organizing our data. So in terms of females, the shortest was 63, and then, oh, excuse me, putting it on the wrong side there. So we got a 63, there's a couple 63s, so we got it, we got that 63, then it looks like we go 65, 66, 67, 268s, and then 270s for the females. And for the males, the shortest male appears to be 67. And we have a 69-inch male, and then we'll jump up to 72. We have 3 males that are 72. 1 male is 73. 1 was 74, and then we had 75, 77. As before, we still want to go ahead and do that legend. So we'll do 6-3, and that's 63. Got our units right there. And then just to make it clear, since the males is kind of going the opposite way, we'll say that's 67 inches, just so somebody can make sure they understand what they're looking at. So that would be a back-to-back stem and leaf plot. And what that allows us to do is now we can start to compare, like, hey, it does look like males tend to be taller than females in this particular group. As we describe the data, there's 4 things we want to think about: shape, outliers, center, and spread. As the unit progresses, we'll talk more about these, but the big one today that we'll touch on is shape. So some of the adjectives that we might use: mound shape, symmetric, skewed, single peak, multiple peaks, as we start looking at this. And as the unit progresses, we'll talk more about how to really identify where outliers are. We'll start talking about different measures of center and different measures of spread. So some of the ways we could describe it: mound-shaped and symmetric. So if you look at these 6 sets of data, if you kind of draw a line over the top of it, all of a sudden you start to see that mound shape, and you can see that it's relatively symmetric on both sides. So it doesn't have to be perfectly symmetric, but you can kind of see the way that plays out. So we could also have something that's skewed to the left. So here we have some data that's skewed to the left. Now, one of the big distinctions for us is understanding the difference between skewed left and skewed right. And it's somewhat counterintuitive, because if you notice, most of the data that's skewed left is to the right. So what you guys are going to want to remember is the skew follows the tail. So if you think about drawing that line over the top of the data, you can see the tail in both of these sets of data, it kind of tails off to the left, so that's why we're going to call it tail, or skewed left. And then you've also got skewed right, so if you kind of follow this, here you see all of a sudden that tail, it tails off to the right. As it goes, that tail is getting bigger and bigger. Alright, the tail's going out to the right. So again, the tail follows the skewness, or skewness follows tail. You can also see something that's bimodal, and here if you draw those lines in there, you see you got kind of the double peak. Right, the data goes down, then back out. So this would be bimodal. If there's more than 2 modes, you might just go with multimodal. Something that might look like it's uniform, right? As you draw that curve over the top, you don't really get much of a curve. You kind of go up, you stay up, and then you drop back down very quickly at the end. Right, so some definitions for some of this stuff, if you wanted to jot those down. So symmetric, one of the big words here for us, if you look at it, guys, is the term approximately. So it doesn't have to be exactly symmetric, but it could be approximately, right? And so here again we go with skewed right as the right side has the outliers. And if you look, the outliers, right, the values that are sitting out here, right, that are kind of all by themselves. And what that's doing, that's pulling the tail down. So that's another way you can kind of look at it, that the outliers are also going to pull the tail one way or the other. So that's how you can get the skewed right, skewed left. So don't follow the data, follow the tail or the outliers. Right? Bimodal, if there's two peaks. Uniform, if it looks like everything's very even as you go. Beyond bimodal, if there's, if there are three or more peaks, you might just go with the term. Let me get something a little bit smaller. You could just use the term multimodal instead of trying to actually go in too much detail. Right, so when to use SOCS, right? If you went back and you looked at the different ways, that's one of the ways you can kind of remember it, right? So you have spread, outliers, center, and shape. Sometimes it's not appropriate. So if you look at the primetime TV censorship bar graph, SOCS isn't necessarily going to be appropriate for this, and that's simply because this is categorical data, right? That's categorical, and there's no rhyme or reason. All of a sudden, I could switch this bar that discusses people opposed to drugs being on TV and naughty words, if you will. There's no rhyme or reason why they're in this order, so all of a sudden things change a little bit. And think about think about spread. How would you quantify spread in data like this? You couldn't really come up with a range. So when SOCS is appropriate is when you have quantitative data. Quantitative data is what you want for SOCS. Right? So at the end of the day, things to remember, the type of graph we construct between the previous video and this one is dependent upon the type of variable that's being analyzed, right? So pie graphs, bar graphs are great for categorical, and then stem and leaf plots and dot plots at this point are perfect for data that's quantitative, whether it's discrete or continuous. Just a quick reminder, right? If we can categorize stuff, it's categorical data, and not necessarily numbers make it quantitative, but keep in mind a big filter for quantitative was, can you take the average? Does it make sense to make the average? And then what you guys really want to start working toward is being able to construct a graph is great. We want to make sure we make good graphs, but at the end of the day, the big thing for you guys, we have to be able to interpret the graph. Right? We want to be able to interpret the graph. So let me get that highlighter a little bit bigger for you, and that's perfect. It's going to be yellow. The big thing for us guys is we want to make sure that we can interpret what we're looking at, and that's where the SOCS comes